Hello everybody, my name is Craig Bennett, and today I'm going to get into a video on aerospace engineering versus software engineering. And as far as things goes, I want to mention a few things. First off, speech problem, whatever. Some people mention it in prior videos, but got a problem with that, get over it. Another thing is my background in aerospace. It's NASA space side, less on the private side. Some private, but less on the private side. So note that. So software wise, I go across the board and whatever, and I got plenty of videos getting into that. If you're curious about that, then check out those. But space side, aerospace side, I basically mine's more on the space industry as far as King Space Center and whatever maybe. And in fact, the thing I'll mention right now is you're going to need a few things if you want to work in aerospace. First things first is you're going to need to have the jobs in your given area if you want to stay there. If not, then choice is made up for you already. And if you can go with either one, check out chemical engineering because they're almost everywhere. But with that one in mind, given that it's in your area and you got choices in what it might be, you need to know the requirements. So first things first is, let's get into requirements first before we get into all these other things. So requirements with an aerospace engineer, it tends to be, not always, it tends to require a ABEX degree. Basically, you need to have a bachelor's engineering bachelor's ABEX. Look it up, and but that's not always. So that's something to note into itself. Now, note with with space systems, you definitely do need that, at least here in the United States. But with airplanes, that's a give or take onto that. It depends on regulations or company policy or what it might be in between for that. Obviously, if you got ABEX, you're going to get paid a little bit more, and you're definitely going to have a higher chance of getting jobs and stuff like that. So that's also something to note. Whereas software engineering, if you don't have a high school diploma, that's cool, and that might shock a lot of people, and a lot of people might disagree with it, but this is just facts. If you have a portfolio, an extensive portfolio with that, so if you got a portfolio of programs you wrote in the past, projects you worked on, stuff like that, then you will have an easier time getting a job. That's the thing that a lot of people don't understand. When you're going through school, whether you go through a degree program to do coding or something else, you need to have a portfolio by the time that you get out. Either your teachers, any projects that your teachers have you do, that needs to be part of a portfolio. But if that's not the case, if you don't get any projects, like for myself, I'm software engineering side, but I'm also going to school. Currently working my last degree, and my stuff's in network engineering as far as my degree goes into. But the thing is the none of my classes, I've never took a single actual coding class. Like the most I've gotten into as far as coding classes goes into is not including outside sources. Like once in a while I poke around with outside sources to see how good things are, but not including that. An actual school class is the coding class. It was Alice. Alice is one of the worst things you can teach someone with. Just look up the reviews on books and stuff if you're a teacher looking into teaching people on coding and think about using Alice. But the fact of the matter is if you really want to go down that path, then you need to really think about doing something else. The fact is go with HTML and stuff like that that's actually useful. Alice was the worst program that I've ever dealt with when teaching someone anything. I don't care what. So with that's my stint as far as coding classes. So 99% of what I know was self-taught. Anything otherwise was probably for something like, I don't know, one of these other third-party things, or you know, to learn from another YouTuber or something like that. So with that one in mind, your degree doesn't even have to relate. Like say for example you got a degree, it doesn't even have to relate into the coding, whereas aerospace, if some jobs require an ABEX, some don't. In some cases, you can get away with not having a degree in aerospace to work in aerospace fields, but most of the time, from what I'm seeing and saw, that is the case. Definitely much so. So that's something to keep in mind. So with that, as far as that goes, again, the biggest thing is if you want to go into management on coding, you're definitely going to need a bachelor's degree if possible, at least associates, but a bachelor's if possible, and that's going to help you get into the management area. But you don't need to have a degree to get into coding, and we're talking about $80,000-$90,000 jobs that you're able to get into with just having the portfolio behind you. Now, it's going to be a little bit difficult for you to get some of those jobs, especially like something like IBM, CNN, stuff like that, where they want degrees behind them. But in some cases, you need to do what's called brand advertisements, which is one big reason why I got this channel. It's called brand advertisements. So what brand advertisement is basically is I teach people about coding. I teach people about all these technical things. In return, I get places like IBM, Microsoft, and a few others that literally have their own HR people to say, a manager will come up and go to the HR person and say, I want to hire this person. Can you talk to them? And they'll send me an email or whatever. We'll talk over it and whatever. Or the manager himself will contact me. That's happened many times. So with that, you don't need to have a degree, but you do need to have a portfolio. With aerospace, having a portfolio is good, but you don't need one to get the job. With coding, you have to have one just to get your first job in many cases. Obviously, if you know someone, then that helps more so. So as far as what you're going to be working on or with, so again, my background in aerospace is space, so rockets. My forte is in rocket motors and stuff like that. So with that, here's some pictures. The first picture, obviously it's a rocket engine and whatever it may be. It's on a display stand and whatever. Thing that a lot of people don't know is these are actual, what you see on displays are actual rocket motors. So the true story, sometimes you'll actually have an engineer that will need something off of one of the rocket motors or just need something in general, and they'll go into the museum, take the nuts and bolts off of a given part of the rocket engine or whatever part, because these are actual parts, and take it with them. I mean, obviously sometimes the person heading the place, they will ask what's going on, but most of the time they'll be informed ahead of time, say, hey, I'm going in, I need to take this, so if you see me, then know someone's not stealing it. It's just it's actually being used. And once in a while you get people try to stop the engineer, but they're like, no, we actually need this to keep doing our job because we're developing something, and these are actual parts. These are not just made up pieces. And sometimes they just take the entire engine itself. So with that, and this is in a testing area. So you would actually hook it up to something like this. This is the pipes and stuff to fuel that a given engine. So obviously some of the stuff will be modified depending on the engine and all this other stuff, but these are the pipes to fuel the engine and to do the test, to heat tests and these other things, sound tests, heat tests, and a few other things. And what you're going to be dealing with is stands like this, giant big stands, and it's going to be you're probably going to be in high places once in a while like this. And basically what happens is you're going to be over a lot of in this case water. I've been over a lot of concrete where if you fell, there's just no two ways around, you'd be dead or permanently injured, like brain damage type of injured. So that's something that normally what happens is when I was out in Kane Space Center, they to prevent accidents and stuff like that, because it happens once in a while, is they got this thing called safety nets. You get it under bridges and stuff, so it's nothing new. Well, what happens is any bolt, anything, if it falls, because it's so high up, if it hits someone on the head, even with them wearing a hard hat, there's a potential it can kill someone. A lot of people don't know this, but for someone, this is something that I am having to go through when I was getting my aerospace training and stuff. OSHA is a major thing out there, and one of the things I learned is someone who falls 3 feet, just 3 feet, if they fall the wrong way. Obviously, if they fall on their arms or something like that, that tend to be protected. But if they fall in the wrong way and they hit certain parts of their head, they're dead. There's just no two ways around it. It doesn't take too many pounds for something to fall down, and even with a hard hat and whatever, and to kill someone or have massive brain damage. So with that, what you have is these safety nets. I never heard of anyone falling in one. I don't know if that's ever happened. I doubt it, but I definitely have heard of stuff like wrenches and stuff like that falling into it. You get the person chewed out and whatever it might be, but those nets are there for those reasons. Even something like a pencil, it falling down, it will hurt someone, oh my, type of thing, but it will, has a potential of hurting someone, and the safety net will hopefully stop it. No guarantee on that one, but hopefully stop it. If not at worst, then it will slow it down and cause less damage. And it's not only the people you're trying to protect, it's the parts, because a lot of these parts, if a little dink, and you're talking about millimeters, can cause the thing to crash all entirely. So you're going to probably be over a lot of water areas like that. And the fact of the matter is again, you're going to be in high places, and how this particular setup works at this given zone is the pipe that you see there, the one going down, the exhaust goes downwards and it goes out. I don't have the a picture of it going completely out, but here's, you can see from the other test stands across the waterway. Basically, it goes out to that, and the water dampens it all entirely. If I could find a picture of the thing going out, I would definitely put it up and whatever. So that's the type of stuff, and this is just at Stennis. So keep in mind, my background's more in Kane Space Center, but you get a chance to go around and see cool things. But these buildings are so well built that they're meant to be used in case of a nuclear blast. A lot of people don't know this, but there's tunnels under a lot of the buildings leading to each of the buildings. So like back in the Cold War, these were built. So, well, none of the newer buildings are really meant for this. Their biggest concern now is like Cat 5 hurricanes and stuff like this, which they are definitely built for. But the older buildings, they had tunnels going between them, and they're built for nuclear blasts, so you can actually go down there, and that way you don't have to deal with fallout and all that stuff. And it's kind of cool, but kind of weird at the same time. So you're going to have to deal with stuff like that in some cases even worse, depending on what country you're going with. You're also going to have to deal with things like this, where you just got rocket or rocket parts laying about. There's been plenty of times, if I can find an image of me sitting on one of the rockets, because there's plenty of times I ate my lunch sitting on a rocket or leaning on one, and or rocket parts, and the thing is you got to deal with that. Believe it or not, the if you got some places like Kennedy Space Center, you'll find sometimes rocket engines right out in the middle of a woods area. Now keep in mind, the places I've been, which is Kennedy Space Center and Stennis, the Kennedy Space Center, both of them are swamp area, so that's a major thing to note into itself. So there's a lot of advantages there. You get to see stuff going in space, see what it looks like when it returns. You get to play around with these type of things. It's cool all around. And you get to see things that people really, average people are never going to be able to see. You get to see things. Here's something that a lot of people don't know. At Stennis, where they were testing the stuff, apparently back in the day, well before I was born, these tests are very, very violent as far as, you know, what they do. And apparently back in the day, and apparently probably still now, I just don't really hear about it, is Georgia. So this is in Louisiana. This is in like Mississippi area, Louisiana area, like right there. Just look up where Stennis is. Well, the thing is Georgia, they apparently have their seismic readers. Whenever a test happens, the seismic reader starts reading and reads as an earthquake is about to happen. That's you know, that's how violent some of these things are. These things are so flippin' loud that no one can be near them at all. It's not the for these type of things, for these rockets, missiles, you can be somewhat around them because they're not as loud, depending on you know, design and stuff. If it's like a buzz bomb or whatever, that's a different story. But if these rockets, the sound itself will kill you if you're near it. If you're close enough, let alone heat and whatever. That's a major thing into itself. Obviously, as these people go up, you know, whatever it may be, the sounds behind them. But the sound of the engines, if you're like right around there, it'll kill you. The push from it at Kennedy Space Center, I don't have any pictures of this, but on rocket stands, if you're out there and if you ever visit Kennedy Space Center, you might be able to see it. They got these patches along the fences. Well, what happens is the push from it, small little pebbles and stuff, they'll hit the gates, the fence so hard it creates these basketball holes because of that, because of the speed of it. In fact, the reason for the water there is not to cool things down, it's to dampen the sound as much as possible. Just like the Stennis, where they had the exhaust go out into the waterway, is to dampen the sound as much as possible. Now, of course, there's tests out there where they don't use the stuff, but they're like 70 miles from anyone. So that's something to note into itself. I mean, this stuff is extremely violent as far as it trying to go off. And just thing to keep in mind, the thing's made to go into space. But you're not going to deal with anything like that in coding. Most, you might, you know, code for a satellite or something like that, but realistically, you're not really going to be around that. You're probably in coding, you're dealing with the equipment that you're dealing with, unless if you're dealing with like something very particular like medical or something like that. Equipment you're dealing with is most likely a computer, a laptop maybe, but a computer, a couple monitors. That's about it. You know, maybe whatever device to, you know, code for it and see it react and whatever, or fix whatever problems there is. But that's about it. There's a massive change. So it's like before where I said you don't need a degree, so that's a plus, but you don't deal with any of this other crap. So, you know, take it as what you will, and there's negatives on that side too. But with that, you know, with aerospace, there's a lot of stress that goes into it. A lot of sleepless nights and stuff like that. The coding the same way, but it's not as bad. Like if you're able to hail a actual job in space, space engineering, aerospace in general, if you hold a job in aerospace in general, it's not the case. The fact of the matter is a lot of people who work in aerospace, they work on airplanes, design new airplanes and stuff like that, so they're not really worried about, oh, is this part going to mess up? Oh, because we're talking about such tight tolerances on these rockets and stuff, that there's a saying that's important to note, is a rocket launcher from Kennedy Space Center in Florida, for those who don't know for some reason. Well, if it goes up and it blows up somewhere midway, then that's Orlando, because what happens is theoretically, if it blows up in just the right way, it can take out an entire city, where and it could be, oh, you were 1 millimeter off of something. You're talking about that tight of a measurement going out through the entire thing, because these little things, because you're 1 millimeter off here, it created all these vibrations on all these other areas, so it rattled apart and broke apart, and you not only killed the people who's riding the rocket, given that it's a manned rocket, but you killed whoever this thing hit. So you just took out an entire school plus 900 other things, and then they got, you know, if it's liquid fuel, depending on the hypergolics, if it mixes, then you probably got explosions there. If not, then whatever the fuel is, you got ecological damage there. If it's a solid fuel, then, you know, whatever that. So now you got a missile that's flying around and doing loops. So you're talking about a bad day. And yes, there is redundancies there. So if you screw up, then hopefully someone else will come out behind you and fix it. But there's a lot of trust on your shoulders. And yes, there is some redundancies there. So if it does go up and it starts to look off, they can, from the ground, order it to blow up, and you know, that's that. But I'm just, obviously you get review and whatever, but there is linear shaped charges on there, which is a charge that looks like a Pac-Man, and it basically, instead of all the energy going out, it looks like a Pac-Man, and all the energy goes into that middle area, which is meant to cut the, like, solid rocket boosters, because once they're on, and there is no off, besides cut them up and have them burn out real quickly, because, you know, something's wrong, you need to get that, and that's that. So with that, and that's where I found it very funny when Elon Musk said, oh, there's a sniper that took out one of his rockets, and he was freaking serious. No, it's you suck. So with that, yes, there is redundancies, but if they don't catch them, then you got all this stuff on your conscience. And there's people who killed themselves. No joke. There's people who killed themselves because they caused someone's death, because they didn't listen to an intern, because they didn't listen to someone else, or because they noticed something and they just didn't speak up, or because they noticed something and didn't think it was anything worthwhile, nothing too pressure. Like, you can't, you know, go for out there every little thing. You have to go with what's the biggest things that can cause problems. So there's actual people who killed themselves over this crap. Not because of stress and whatever, but when something happens that they're like, they blame it on them, and it's bad. Now there's a lot of people who move on or whatever, but you know, you never want that to happen, and there's a lot of stress goes into it. Whereas regular airplane stuff, the engine goes out or whatever goes out, as long as the wings stay on it, it's a glider now. Where this rocket, that's the difference. That's one thing I want to mention right now. So it depends on which area. If you're going for space, there's a lot more stress involved. With airplanes, okay, you just made a glider that now has to somehow glide in, and hopefully they can call for Mayday anytime and all that stuff. But you know, that's what we made. Now obviously, again, there's redundancies there to keep these things from happening, even criminal, where if you screw up, and you sign off on something and it caused someone to die or some mass problem, you can go to jail for that. A lot of people don't know that. But these are stressors that you need to keep in mind that are there. Whereas with software engineer, that's not the case. There is some things that could lead you to jail, but very few. And the things that keep you up at night is more than not problems that you're trying to solve for. Not that, oh, will this kill someone? Will someone's wife, husband, child, whatever, father, mother, will they not be there tomorrow because of something? You're not worried about that when it comes to software engineering, for the most part. There might be some scenario that, like military, whatever, that, it's whatever, but for the most part, you're not worried about that. Whereas aerospace, you definitely are. That's the forefront of your mind almost all the time. So that's a major thing to note. So you're definitely going to know stress when it comes to aerospace, not because of the math and all that stuff that goes behind it, but it's because there's a real chance that a small slip up can cause someone's life. But as far as software engineering goes, let's see if I can think of something bad. Something bad about software engineering is you always have to learn about something new. There is no stop on it, and there's no. Usually, if you're in a formal class and a formal degree program and stuff like that, by the time that you get out from the start to the end, whatever you learn is outdated to some point, if not completely outdated. So things move so fast that you constantly have to learn things. This is in IT in general, but you have to keep that one in mind. Whereas in aerospace, the laws of physics are the laws of physics. In aerospace, if today throwing this whatever with how much force behind it gets it whatever far, unless the Earth sped up or did some wacky crap, it's going to be the same tomorrow, same 300 years from now, same a billion years from now. As long as the Earth doesn't do some wacky crap, or you don't have stuff, some wacky stuff that's going to be major problems to start with. Unless of that, it's always pretty much going to be the same. So once you got it down pat, there's not much of a worry. You can basically go in and not have to worry about, oh, what next do I have to learn? What next do I have to study up on? You're always going to keep notes and stuff like that, and study things like how you got to whatever solution, math-wise or whatever it may be. But you're not having to worry about, oh, today if I throw it here, it's going to land 2 feet, and tomorrow, same force, same everything else, it's going to land 40 feet. You're not worried about that type of stuff, because with devices, like say for example with phones and stuff, today one of the biggest things that a lot of application developers and stuff like that is worried about is the fact of battery. Battery is a major concern, and the biggest thing that sucks down the battery is the antenna use and things like of this nature. Obviously the screen, but there's nothing you can do about that. So the antenna use. Well, tomorrow it's going to be about something else all entirely, because the battery issue is going to probably get a fix. So you're going to have to worry about this other thing, and it goes down that line. And even then, it's like you got things like VR. So one day it's going to be like you got to learn VR because the competition knows VR type of thing. Where in this case, it's not like, oh, you got to learn about how you can get this go 3 feet further with the same force because Mars has it 3 feet further with the same force. That's not the case. The fact of the matter is, with aerospace, you don't have to worry about all these things. What you know from this year to next year to 5-10 years down the road, it's all about going to be same on aerospace. There might be some changes on With metals, there might be some changes with the actual materials that's used, but 90% of it is going to be basically the same. Whereas with coding, that might not be the case at all. For all we know, it might happen where that everybody starts wearing these contacts. Then they might develop them tomorrow where contacts will replace computers. That's for all we know. Then that's going to change the entire aspect. Or like say 2% of the market starts doing that. Then we're going to do that and code that into our systems. That's the thing to keep in mind. Now, of course, things that that people on the aerospace side have to keep in mind is regulations and stuff like that. But for the most part, those are very stable in into itself. You just got to make sure that you properly document things and sign off on the right areas and stuff like that. So with that, that's a major thing to note. Is with coding, you're obviously going to learn something new and have to keep up with what it may be. Now, as far as that goes, last but not least, I want to mention that with software engineer, the thing to keep in mind with that is while the jobs tend to be more secure as far as you get in what's called a peacetime, there's nothing like, again, as I said, hopefully said before, the aerospace engineering is basically you get in a door, you have to develop something, either modify something that's currently existing or develop something brand new. You go ahead, and in the peacetime, you don't really have jobs at all, but in crisis time, your jobs pick up, or you hire whatever that lost their jobs. So basically, you're only working on the development or crisis. Where a software engineer, it can work in that peacetime. Well, the thing is many of the companies that you might be working for, they might not last that long. That's the one thing you also have to keep in mind. Aerospace engineering companies tend to last a lot longer. They tend to not have these type of problems at this time. This might change when flying cars come around and stuff like that, but if that ever happens. But with at this time, the aerospace jobs, they tend to be not stable, not secure as far as they go, but their companies tend to be very, very secure. So as long as you're rubbing right shoulders and stuff like that, and you're able to prove why you need to be there, why something needs to be modified, why you need to do this, this, and this, and as long as the customer base is still there, you're good to go. With this other, no matter how good you are, your company might go up in flames, next day, and this happens a lot unless you're getting something like IBM or Microsoft or something like that. So with that, that's just some things to note. So hopefully that helps you out and whatever it may be. If you got any questions, leave them, and I'll see you next video. Hope you have a great day.